questions. Thank you, Ms. Cooper and Mr. Simler. All right, so I'm on page 51. Hard to believe. It's the last lesson. The last lesson in Unit 2. We have been sprinting through calculus, and the sprint continues. Page 51. All right. My paper picker-upper, Carmen? Carmen, I don't know why I have brain damage and I cannot remember you're the paper picker-upper. And you pick up the paper so perfectly. I should remember this. All right, Carmen, if you could go pick up the paper, please. All right, so last little thing. This truly is the multiple choice from last night. Okay? You're going to get this back tomorrow. Don't worry about it. So the absolute last thing that comes in this unit before the unit test is looking at derivatives numerically. We've done a lot with the derivative in this unit. We've looked at derivatives when I give you the graph. You've got the graph in front of you. And the question to ask yourself there all the time is, which graph am I looking at? Is it f? Is it f prime? Is it f double prime? Is it the antiderivative? We've done number line test stuff. I don't give you the graph, but I give you a polynomial. We've looked at derivatives on the calculator. We've looked at derivatives in the world of physics. And in the world of physics, you know that if you start with the position function, we know in the world of physics, if I start, all the side conversations need to end. I feel like I'm talking just to my friends at North Central right now. Okay. In the world of physics, if I give you the position function, and I take a derivative, I'm going to get?
The velocity.
How about all the rest of the brains? If you start with the position function and you take the derivative, you're going to get?
Velocity.
Velocity. Take another derivative? Acceleration. What if I tell you that at a particular point the velocity is positive and the acceleration is negative?
Speed.
Velocity positive, acceleration negative, polynomial, tell me about speed. Speed decreases. What if I said velocity is negative and velocity is decreasing? Conclusion, stop and think about that one. Velocity is negative, velocity is decreasing. Aaron, what's your conclusion?
Speed is increasing.
Speed is increasing, because when I said velocity is decreasing, what you really heard was?
Well, they're doing the same, they're changing the same way.
Because if velocity is decreasing, acceleration is negative. When velocity and acceleration have the same sign, velocity is negative, acceleration is negative, speed's increasing. Velocity positive, acceleration positive, speed increases. Everybody good?
Mm-hmm.
So we've looked at derivatives from graphs, we've looked at derivatives from the calculator, we've looked at derivatives in the context of physics, we've done number line test stuff. Here's the last thing, it's called derivatives numerically, and I gotta tell you, this shows up on the AP exam every single year on the multiple choice. And it winds up being one of the hardest things for teenagers to do. It is always the lowest scoring question. For some reason, even though I put it on the unit test, every single year, including the one you will take tomorrow night, it winds up being the lowest scoring question. It's then going to show up on the semester exam that you're going to take in December, and it might be the lowest scoring question unless this is the year that we break the curse. I would like for this to be the year that we break the curse. So here we go. Here's how the problems are going to read. Okay, for all values of x with -2, less than or equal to x, less than or equal to 2, the first derivative is positive and the first derivative is increasing. You've got a bunch of data points here. You need to decide which of these data sets, it's over there on the table, satisfies the condition that first derivative is positive and first derivative is increasing. So, if I told you the first derivative is positive, f prime positive, what are we looking for in f? F prime is positive, so f is increasing. Don't overthink it. F is increasing. We know that for a fact. Based on that one little bit of information, Are there any of these data tables that cannot be? I'm not going to pick A, and I'm not going to pick D. 4, 2, -1, right? Those are not increasing values, those are decreasing values. So it sounds like we've got B, we've got C, or we've got E. We're good? Easy peasy so far? Now here's the other part. The first derivative is also increasing. If the first derivative is increasing, there's a lot of things you guys could tell me. If the first derivative is increasing, you could tell me that F is, this means that F is concave up. The other thing that you can tell me about F double prime?
Greater than 0.
Is greater than 0. So let's see, I know that the graph I'm looking for is increasing and concave up. Can you guys draw in the air what that would look like? The graph is increasing and concave up. Increasing, concave up should only look like that. We've already used the increasing part. I think the tough part tends to be the concave up. If you're concave up, it means that your slopes are increasing. That means that like you're going to increase by greater and greater and greater amounts. Let's look at the ones that are left here. I'm going from -3 to -2. That's an increase of, what is that? An increase of 1, an increase of 2, an increase of 3, an increase of 4. My increases are increasing. I'm increasing by greater and greater and greater amounts. Whereas this guy over here, I'm increasing by 2, by 2, by 2. What kind of function is that? Every time my x value increases by 1, my y values are increasing by 2. There's only one kind of function that we know that does something like that. Linear. Not concave up, not concave down. This guy down here, I'm doing an increase, what, by 4? By 3? By 2? My increases are getting smaller, which means concave down. Okay, so I think we've already established what the right answer is here, right? Number 1 should be B. So 1 is B. Check. Everybody good? All right, one last thing that I want to do is this. Why is she calling it? All right, we've got number 1 goes with B. Now, the other thing they're going to ask us to do sometimes with the derivative, they're going to ask us to approximate the value of the derivative. And here's the thing. To find f prime of 1, normally what you'd want to do is you'd want to have like 2 points.
Wait.
Yeah.
You're still talking about question 1, right?
So number 1
Oh,
matches with data set B.
okay.
In data set B, I want to approximate the value of the derivative at 1. Everybody okay? Now what Newton tells us to do, if you want to approximate the derivative, you pick another point. Right? And well, the problem is in this data set, I can't get super close to 1. I only have these 2 points available. So what I can do is I can say, well, I'm going to approximate f prime of 1 by doing a slope calculation. I'm going to say it's 3 minus 0, change in y, over change in x. And I can approximate the value of the derivative at 1 as 3. Or, what if I go in the other direction? I might say, let me use these points here, and f prime of 1 is going to be approximately 7 minus 3 over 1 minus 0, which is 4. The actual value of the derivative isn't 3. The actual value of the derivative isn't 4. What I know is that my function is increasing and concave up. If I'm increasing and concave up and my function looks like this, here's x equals 1. If I use x equals 0, you guys told me the slope is like 3. If I use the point that comes after, the slope is 4. The true value of the derivative at x equals 1 isn't 3, that's an approximation. It isn't 4, that's an approximation. The true value of the derivative is somewhere in between 3 and 4. So what I can say with confidence is that f prime of 1 has to be less than 4, but greater than 3, because my graph has to be increasing in concave up. What questions are out there? Everybody's okay? All right, let me get out of your way. Let me give you guys a little bit of time to practice. You've got 1, 2, 3, 4 more descriptions of the data. Hold on, Celeste. With each of the descriptions of the data, your goal number 1 should be take the description, match it with the right data set. Once you've got the right data set, come up with an approximation for the derivative at 1. Celeste.
For when you take the derivative of the point after,
Yep.
why is it 1 minus 0 on the denominator?
Why is it 1 minus 0 in the denominator? It's not. Thank you for making me a better teacher. It should be 2 minus 1. It's still 4. Okay. See what you can do. Here's what I really care about. I care about, can you match the verbal description to the numerical values? Show me that you've got all those matches, then go approximate the value of the derivative. Sir. Feel free to talk to the folks that are around.
Where do you put the G? Strictly decreasing.
And then it's going to come down, so it has
The function is strictly
Number 2 is
decreasing.
wait, what?
Because of that, the concave down.
Should be based on concave down.
Okay, so tell me what. Okay, be careful, not it. F of x is decreasing. Oh, because first derivative is negative, so f is decreasing.
Oh, you said the function
Just the
is
functions first.
First derivative positive.
The function is strictly decreasing. Yeah, my apologies, my version here is a little bit different than what you guys have. Okay, the function is strictly decreasing and concave down. So if I'm decreasing and concave down, I'll look like that. Decrease and concave down. Okay, we've already picked these. So we're going from 3 to -1 to -4 to -6 to -7. Definitely decreasing.
Well, you're saying.
Concave down, I'm going to be decreasing by greater and greater and greater amounts.
I'm doing my work.
So I'm decreasing by -4, by -3, by -2, by -1. So you guys are matching it with that one. Wait, say?
Oh, I should already check this.
Yeah, I don't think I agree with you guys on that one. Yeah,
Can you check these?
okay.
Is it A?
If F is decreasing and concave
What?
down,
Because we're doing this. It's saying the function.
Is that one?
the function is decreasing and concave down.
Is that one or 4, 3, 2, 1?
Yes.
Okay. It is A then?
No.
Oh, well.
Number 1 matches with B. Number 2 matches with A. Yes. Okay. Yep.
Okay, I know what I do.
It's just,
Because you guys are good with con.
because it's, the values are decreasing,
Oh,
we'll agree on that, but then it's concave down, because the rate at which they change is decreasing. Because this one is concave lower, because the rate at which they change increases. So the opposite.
When you're talking about concavity, you're just talking about the rate, you're not looking at the negative part, you're looking at the rate is increasing and decreasing.
If I was like -10 minus -5.
Because minus 1,
-10 minus -5.
minus 2 is
Like this can really concave down.
If my function
Even
is
this can be
decreasing
concave down because the rate at which it's increasing is decreasing.
and concave down, so concave down, my slopes should be becoming more negative, right? So which one?
You just look at what the rate change and increasing it. Just look at the concavity. That's-
Shouldn't that be
So the first.
You didn't
I mean, decreasing, concave down?
check.
What's going wrong?
all
-1. My slope is -4, -3, -2, -4. Why am I having a total brain fart here?
Which one?
Number 2.
Is D?
If F is
It might be D though.
decreasing and
Because the-
concave down,
Because the rate of change
It
is
should be A.
decreasing.
It should be,
It's A because of the concavity.
because the values are decreasing, and then the rate at which they decrease is getting smaller.
It has
What's
to
A?
be smaller.
Think about it.
right? So we're saying the slope here would be like approximately -4,
Right, and it's decreasing.
which is a big negative number,
Right.
2 is negative.
and then a small negative number, and then a smaller negative number.
Yeah.
So I should have, my data is decreasing,
Yes.
and the changes are increasing.
Because from -4 to -1, it means that -4
Yeah,
is greater than -4.
that's D.
Wouldn't it be D then?
Right, which means that
Okay.
my function here is decreasing
They said it was-
and
this would be
Concave up.
concave up. Decreasing concave up ought to look like that.
Because the rate of change is becoming more and more negative at D, on D.
Yeah. and then
The rate of change is becoming less negative.
I'm talking about for D.
But for
Oh, in D.
It's becoming more negative.
Right, in D,
And
if I look,
That's why
this
we
is
thought
a
it was-
decrease
that's why I
of
said it was
2, this is a decrease of 3, a
Makes sense.
decrease of 4, a decrease
That's
of
what I'm saying,
5.
it makes sense.
The Y values are decreasing
Because,
by
no,
amounts that are more negative. So this should be decreasing concave down.
when you're
So I'm looking for that.
when you're drawing.
Oh my god, we went back.
Slow it.
like
So-
4 times.
No, it's just 'cause it's-
2 goes with D.
Me too.
It's steep.
Okay. All right, number 3, what do we get this going with?
This is complicated.
The first derivative is positive. If f prime is positive, then this is f increasing. Second derivative is negative, means f concave down.
E.
I need increasing concave down, which does that. And that should match with E. E, so number 3 goes with Aaron. You're killing me. Okay, number 4, f is monotone increasing or monotone increasing. It's boring function. All it does is increase. And the second derivative is equal to 0.
C.
C.
That has to be C.
Yes.
Right, monotone increasing, so f prime is always positive. Second derivative is 0, which means f prime is constant. I need a function that's increasing and constant. Right, plus 2, plus 2, plus 2, plus 2. For sure, number 4 goes with C. And process elimination, it must be that number 5 goes with A. Whew. All right, how are we doing?
This is the easiest one to do.
That was the easiest one for you
No,
because this is how your brain's wired.
numerical, the-
I think where I blew it is I changed my numbering system on my paper from what you guys have, and everything fell apart, so this paper just needs to get destroyed and never come back. All right, so on your own, try number 2 on the multiple choice on the back.
Oh, this is late.
And for all the friends at North Central, sorry about that, I didn't get nearly enough sleep last night. Number 2.
We said this big one, but it's-
I like it. So it's f prime is greater than 0, that means f double prime be increasing. Right?
By yourself.
Okay, he wrote capital.
Okay, friends over here, let's stop playing with cups. Number 2, f is a function, f prime of x is greater than 0. Big F increasing, f double prime is greater than 0. So I need increasing concave up. Is everybody okay with what the graph looks like? Increasing concave up. David, give me one of the data sets that you're not going to use.
A,
You're not going to use A. Tell me why you're not going to use A.
because the f of x is decreasing.
Those values are decreasing. We're not going to pick A. Giselle, give me another one that you're not going to pick. E, you're not going to use E. Why? We're going from -3 to -4 to -3 to 0. Okay, so we actually, it looks like we start decreasing, then we start increasing after that. All right, Myra, give me another one that you're not going to use. You didn't use A or E. Good. Okay, so it sounds like you are considering B, C, or D.
Not
You're not considering D. Why not?
because the slope is positive, but it's
Okay, we're going from +8 to +6 to +2. My slopes are decreasing. Not gonna pick that. Lewis, give me another one that you're not gonna pick.
C.
C, why not?
Because the slope is constant.
Your slopes are constant. You're increasing by 3 every single time. So Aaron, which one are you gonna pick?
B.
B. How many guys honestly pick B? We got this under control?
Yeah.
Good.
E is concave down, right?
Yes.
Because your data points are increasing, but by smaller and smaller and smaller amounts. So you're increasing but concave down.
Look at you.
Yep.
Doing that.
All right, number 1, good luck.
Ooh, what? Alright, good luck.
Good luck, you're gonna need it.
Alright, good luck, son. It's bad.
It's 20.
Don't fall for it.
Alright, go for it.
Don't fall for it.
Oh, wait. We do.
There's one,
Oh, I got it. I
two,
hope I got it.
3 people falling for it.
Wait, did you look at my paper?
Possible.
Wait. You like
I think he's saying the phone. He told him not to phone her.
Oh, my God.
my boy, hold up.
Oh crap, nope. I don't know what I've fallen for.
I saw you.
All right, time to vote. How many guys going for A? B,
I don't.
C, D, E. How many guys have no idea? Be honest. Thank you for the honesty. Thank you for the honesty. Okay, we're trying to find f prime of 3, which is a derivative. You're going to approximate it by finding the slope. Now here's the mistake. Here's the mistake I kept seeing. Increase by 1.2, increase by 1.8. And you're like, oh, the derivative must be between 1.2 and 1.8.
No.
That's wrong.
Why is that wrong, David?
Because that's the difference between 3 and 5, and we need to look for like first one to like.
Right. When we look at slope, slope is a measure of the change in y over the change in x. And all the problems we were doing before, it was a change of 1 on the x coordinate, and so it didn't matter if you looked or not. You need to look. So this would tell me that the slope over here is approximately 0.6. Slope over here is approximately 0.9.
So point two.
If the graph is going to be concave up, right, that means my slopes have to be increasing. They go from like negative to less negative to 0 to positive to more positive. So I need my slope to be between 0.6 and 0.9, but not 0.6 and not 0.9, which means that the only right answer is B, which means that Aaron and Polymon are the only 2 that are correct.
Damn.
I can't believe the rest of you made me actually say that. Thanks for putting me in that situation. I'll remember that forever.
Only thing I'm good at.
All right, on your own, problem number 3. If Polymon and Aaron are the only 2 that get this right, we're gonna cancel the class forever. It'll just be me and the North Central kids.
Y'all put A.
Oh, and the East End babies.
Wait, they're East End babies?
There are East End babies too. We've got explorers on the line.
Exploring thing.
S is increasing. A little sketch goes such a long way. David, how do you get velocity? If they've given you distance, how would you ever find velocity? Derivative, right? So I'm looking for an estimate for s prime of 3. So I can see where 3 is on the table. I see the change here, what is that, 37? And we're not gonna make the mistake, we're gonna check the change in the x value as well. S prime of 3, the only good looking answer here. Has to be B? How many guys honestly had B? Okay, we've got B under control? Okay, good. All right, so here's what I want to do. We've got not nearly as much time as I was going to hope for. That's okay. It's a little bit bad planning on my part, which is never okay. All right, so let me tell you a little bit about what I want you guys to do. We're going to start this today and keep going tomorrow. All right. So Miss Cooper from Southeast, Mr. Simler from North Central, and I put together some new review questions that have never been seen by the calculus students before. We did this based on what we know about the unit test that is coming your way. We did this based on problems that we know kids have struggled with. So I would encourage you all to start with question number 1, specifically parts C, D, E, and F. The smart teenagers are the ones that are going to use the next 6 minutes to see what they can do with C, D, E, and F. I want you to skip A and B. I am not interested in A and B right now, just C, D, E, and F. If you need help, use the cups. If your cup is on green, that means you're okay. C, D, E, and F, that means you're flipping the page over, and there's no letter F there. Bummer. There's an implied F there, Lewis. I promise I'll be that careful when I'm grading your quiz and your test. So C, D, E, and F. If you need some help, use the cups. The tallest person in the group is in control of the cups.
It's a turtle.
No, you.
Yeah, going turtles.
You're here Come on.
C, D, E, and F. You're right there, David.
Yeah, that's fine.
Is it one?
Everyone seems pretty convinced that on part C, the piece you're missing is the slope at -1. I've not seen anybody with the correct slope at -1 though. So it seems like I just want to interrupt real quick. Everybody has L of x equals something times x plus 1 and then plus 2. It's figuring out the something that's the problem.
It's 2/3, right?
2/3? No.
Is it one? Is it one?
No.
1/2?
This is not an option. Okay, here's the thing. I am convinced that you all know what you're looking for is the y value over here, right? You need the y value. Well, that point is on a line. Anybody know anything about this line? It passes through the point 0, 2. It passes through the point -3, 0.
The whole time.
There's a same slope all the way through, and the slope there is -2/3. Positive 2/3. Now here's where I want to be careful, is the slope of this line. It is not the y coordinate at this point. Right, this is the graph of f prime. What you guys are looking for is not the slope of this line, but what's the y coordinate at this point. When I know what the slope of 2/3, I'm going to rise 2 and run 3. To get to this point, one thing you could use, you could say, well, what's the equation of the line? This is going to be the line y equals 2/3 x plus 2. You know the slope, you know the y-intercept. What's the y coordinate at -1? Shouldn't it be 2/3 times -1 plus 2, which is 4/3? The y value there is 4/3, a little bit greater than 1, not quite 2. So my equation is going to be that L of x equals 4/3 times x plus 1 plus 2. Now here's the thing that I really care about. Part D. Using your answer in part C, use the tangent line to f of x at x equals -1 to approximate f of -0.8. This showed up a lot on the last quiz. F of -0.8, I'm going to use the tangent line to approximate this value. You've got to be careful with what you write next.
Squiggly line.
Well, the squiggly line would be nice, but it's f of -0.8 that you're approximating. So f of -0.8 is 4/3 times -0.8 plus 1 plus 2. Don't simplify, you don't need to simplify. The mistake is a lot of folk don't even write this. They were saying L of -0.8 is approximately that. That's not what you're being asked to approximate. They want you to approximate F. Now, the question that I'm honor bound to ask you, overestimate or underestimate? There's 3 things I'm looking for. Number 1, what's the interval? What's the interval? You've got to go from your point of tangency to the point that you're estimating. So from x equals -1 to x equals -0.8. Does anybody know the concavity of f?
Yeah. Concave loop.
From -1 to -0.8, this is the graph of f prime. F prime is
Concave.
f prime is increasing. So f is
Concave loop.
f prime is increasing. So what do we know about f?
Concave loop.
F is concave up. If f is concave up, what do we know? Tangent lines are where? Draw concave up for me. Where are those tangent lines? Below. Are below, which implies an underestimate. All right, tonight's homework is the quiz. You have got to get the quiz done in the amount of time allotted. Do not forget it in a locker. Do not forget it at home. Don't let your dog eat it. It's due tomorrow. See you later.
Oh, perfect.
Man, who's gonna econ?
Why you not that tested?
It's perfect. What's perfect? Perfect
No one
timing.
to be.
I tried.
Better read it around.
I want to break.